a cometary tail that goes away from the sun because dust and gas are being pushed by the solar radiation and wind. In this case, it was looking different.
There's a very strange object flying through our solar system right now. We don't exactly know what this thing is, or what it's doing. In fact, for the moment, we can't even see it anymore. But we have been watching this object, named 3I Atlas, very closely for months. In just that short time, there have been a ton of research papers published on it, and there is plenty of other information out there that sounds pretty insane. So today, we're going to cut through the noise and get to the bottom of everything you actually need to know about this new interstellar visitor. So, how did we even find this thing? Well, on July 1st, 2025, a system of telescopes called ATLAS spotted just another moving object in the sky. It was given the forgettable name A11PL3Z, and they were ready to move on. But then, they noticed something really weird about this one. It was moving too fast. Okay, so to understand why that's a big deal, think about how our solar system works. Everything is constantly moving, orbiting the sun because we're all stuck in its massive gravity well. The fact that we're moving sideways is what keeps us from falling in. But if you start to move fast enough, you can actually start to climb out of that well. If you reach a certain velocity, what we call escape velocity, then you break free completely from the sun's gravity and fly out into the void between the stars. And when astronomers clocked the velocity of this new object, they were shocked. It was moving so incredibly fast that there was no way it came from around here. It was a visitor, a true alien from interstellar space. This makes it only the third interstellar object we've ever seen. You might remember the first two. One, E Oumuamua, the weird cigar-shaped rock from 2017, and 2E/Borisov, which looked pretty much like a normal comet, just one from another star. But 3E Atlas seems to be something else entirely, a kind of strange hybrid of the two. And the best part? We caught this one on its way in, giving us a front row seat to watch it wake up as it gets closer to our sun. The moment we confirmed this thing was from outside our solar system, it became an all-hands-on-deck situation for astronomers. Everyone pointed their most powerful telescopes at it. We're talking about the big guns, the Hubble Space Telescope, the Very Large Telescope, and the real game changer, the James Webb Space Telescope. This wasn't just about getting a cool picture. It was a full-on cosmic investigation. Each telescope has a different job. Hubble gives us those super clear pictures of its overall structure. The VLT is like a chemical lab. It splits the light into a rainbow to see what elements are there. But JWST is the key. It sees in infrared, which is basically heat radiation. By looking at the heat signature of the gas cloud around the comet, it can essentially taste the exact molecules coming off its surface. This is how we figure out what it's made of, where it came from, and what that can tell us about the star system it used to call home. The investigation was on. And as the first results started coming in from that investigation, things got even weirder. It turns out 3E Atlas is not made of the same ingredients as our local comets. It's a completely different recipe. The biggest surprise was a shocking lack of water. Okay, so most comets in our solar system are essentially dirty snowballs. As they get near the sun, that water ice turns straight into gas. That's a process we call sublimation. And that's what creates the fuzzy halo and tail we associate with comets. But JWST looked at 3E Atlas and found that while it was highly active and producing a huge gas cloud, there was surprisingly little water vapor. Instead, its coma was overwhelmingly dominated by carbon dioxide. Now, why does that matter? Carbon dioxide freezes at a much colder temperature than water. This is a profound clue that 3E Atlas likely formed in a really really cold region of its parent star system, a planetary construction zone very different from our own. But the chemical weirdness didn't stop there. The Very Large Telescope also detected atomic nickel vapor in its gaseous halo. While finding traces of metals in comets isn't completely unheard of, seeing it in an interstellar object just adds another layer to the puzzle. This chemical cocktail, extremely rich in carbon dioxide, low on water, and tinged with nickel vapor, paints the portrait of a truly alien object. It proves that the building blocks of planets aren't uniform across the galaxy.
Okay, let's talk about the tail, because this part caused a lot of confusion and some pretty wild speculation. Early on, observers saw a prominent feature that appeared to be aimed towards the sun. Comets are supposed to have tails that point away from the sun, so this was immediately called an anti-tail, and everyone started wondering how it could be defying the fundamental forces of the sun. So, what was actually happening here? Well, first, an anti-tail is often just an optical illusion. It can happen as Earth passes through a comet's orbital plane, and our viewing angle makes it seem like heavier dust particles trailing behind the comet are pointing the wrong way. However, with 3I Atlas, it was a little more than just a line-of-sight trick. High-resolution images revealed it to be a powerful, jet-like structure being forcefully ejected from a specific point on the comet's rotating nucleus. Think of it like a spinning pressure cooker with a vent. The mystery deepened when, as the comet traveled closer to the sun, the tail's appearance changed, transforming into a more conventional tail pointing away from the sun. This wasn't some kind of braking maneuver like you might see in a sci-fi movie. Instead, it was a beautiful demonstration of cometary physics. Scientific models explained that as the comet heated up, the material being ejected changed from larger ice grains to smaller dust particles, which were then more easily pushed back by solar radiation to form a classic tail. So, while not a physics-defying anomaly, it was a really rare and valuable spectacle to see happen in real time. So the next big question is, how big is this thing, really? Trying to measure the solid core of a comet is notoriously difficult because it's completely obscured by that vast, glowing coma. Early estimates were all over the map. However, more precise data gives us an upper limit of just 5.6 kilometers, about 3.5 miles in diameter. And its most likely true diameter is even smaller, possibly less than 1 kilometer. So it's not a monster comet, but its importance isn't about its size. It's about its origin and its age. By tracing its path backward, astronomers estimate it comes from the Milky Way's thick disk, an area populated by older stars. One study estimated its age at a staggering 4.6 billion years, making it roughly as old as our own solar system. Think about that for a moment. This small object has been wandering the galaxy, a silent, frozen time capsule from another star system, for billions of years before, by sheer chance, passing through our little neighborhood. Okay, we have to talk about the elephant in the room. Whenever an object from space displays unusual characteristics, the question inevitably arises: could it be artificial? With its strange chemical makeup and its initially bizarre tail, 3I Atlas was no exception. This line of thinking has been most publicly advanced by Harvard astronomer Avi Loeb, who suggests that we should at least remain open to the possibility that this is a piece of extraterrestrial technology, a technosignature. The argument is that when we observe things that don't neatly fit our existing models, we should consider all possibilities. Some even speculated that the tail's transformation could be seen as a deliberate braking maneuver. However, and this is a big however, it is crucial to state that this remains a highly speculative, fringe hypothesis. The overwhelming consensus in the astronomical community is that 3I Atlas is a fascinating but entirely natural object. As NASA scientists have been clear, it looks like a comet. It does comet things. For every supposed anomaly, there is a plausible natural explanation that is consistent with the evidence. Its unique chemical composition is a powerful clue that it formed in a different stellar environment. The tail is explained by the physics of outgassing and particle dynamics. At this moment, every piece of evidence points towards 3I Atlas being a natural, albeit exceptionally interesting, interstellar comet. So let's talk about the journey of this interstellar object. Right now, 3I Atlas is making its closest approach to the Sun. We call this phase perihelion, and the peak occurs on October 29, 2025. At that point, it will be about 203 million kilometers from our star, a path that takes it just inside the orbit of Mars. It never posed any threat to Earth, but this is the time of peak activity for the comet. This is the hottest that it will get, which means a lot of material from the surface is going to get blasted out into space. It's a spectacular piece of cosmic ballet, and unfortunately, we don't get to see this happening as it flies through its peak exposure. Why? Because we are on the wrong side. Call it bad timing or something else, but our view of the perihelion is completely blocked out by the glare of the Sun. To look at what's next. In December 2025, 3I Atlas will once again be observable by telescopes like JWST and Hubble. This is perhaps the most critical part of the entire investigation. The intense heating could have dramatically altered the comet. Did it fragment? Did it open up new vents on its surface? Seeing how the comet has changed will provide invaluable information about its structure. From there, it will continue outwards, destined to return to the interstellar darkness. So, what does this all mean in the broader context? 3I Atlas isn't just a single, isolated mystery. It's the third data point in what is becoming a galactic census. First, there was 1I/Oumuamua. It was small, reddish, highly elongated, and, most perplexing, it lacked a visible coma even as it sped up. Then came 2I/Borisov, which was a relief to many astronomers because it looked and behaved almost exactly like a comet from our own solar system. And now we have 3I Atlas. It serves as a fascinating bridge between its two predecessors. Like Borisov, it is clearly an active comet, but its chemical composition is far more exotic. It's like trying to understand the geology of Earth by studying just 3 grains of sand, one from a volcanic beach, one from a white sand beach, and one from a rocky shore. Each one is different, and each one tells you something new about the environment that formed it. With every new interstellar object we find, our understanding of the galaxy's chemistry and the variety of planetary systems grows a little bit richer. The story of 3I Atlas is still being written. New data from its journey away from the Sun is expected in the coming weeks and months, and it could hold even more surprises. If you want to stay updated on this interstellar mystery, make sure you subscribe. From a faint smudge of light to a global astronomical event, 3I Atlas has provided a tantalizing glimpse into the galaxy beyond our own. It is a natural object, but one whose alien chemistry is forcing us to broaden our understanding of how planetary systems form. It leaves in its wake a trail of groundbreaking data and a renewed sense of wonder, a free sample from another star system, delivered right to our celestial doorstep. And it serves as a profound reminder that the universe is far stranger, more varied, and more magnificent than we can possibly imagine.